This chapter is on, this lesson, is on exploring square roots. We're going to talk about, in the opening, what square roots are. It's helpful to draw pictures of some squares to think about this. So if I have a square that has 4 squares in it, it would be a 2 by 2. Let this represent the number under the radical of the 4, these 1, 2, 3, 4 squares. And the solution to the square root of 4 is the dimensions of the square, which is 2. So if I did a square of 9, I would be showing sort of a representation of the square root of 9. And we get the answer to this, or we solve this by saying, what are the dimensions? How far is it from here to here? So that would be 3. And without drawing any more squares, you can probably figure out the square root of 16. Another way to think about it is, what number do you multiply by itself to get 16? What number to the second power equals 16? And that would be 4. And I'm going to break the pattern now and say, what's the square root of 81? Think what number you multiply by itself to get 81? And hopefully you're thinking 9. This is a representation of a square root graph. This would be the number that you're trying to find the square root of. So if you want to know the square root of 4, you go over 4 and up to what the square root of 4 is, which would be 2. If you want the square root of 9, this is kind of a hard chart to use because the intervals are 2, but it's very hard to count half of that to know where is the number 9 at. It's actually right in between these 2 vertical lines. And you can go over and see that's a 3. And you can use this kind of a display to figure out what's the square root of a number that's not a perfect square. Like between 2 and 4, there's a number that's not a perfect square, which is 3. The square root of 3 would be whatever this value is, which looks like it's about 1.8. Or you could look at a chart like I want to draw over here, where I have, if I want to know the square root of 1, I can say 1. The square root of 2, I'm going to leave that blank for a second. Square root of 3, square root of 4, which is an easy one, that's 2. And the last one I have room for is going to be the square root of 5. So let's scoot that up a little bit. Now, before I started making the video, I used my calculator to figure out what these values were, like the square root of 2 to the nearest 10th. And I know that's 1.4, but that's just a rounded off sort of an estimate of the square root of 2, because the square root of 2 would be 1.4 to the nearest 10th, but it would go beyond the decimal to the right an infinite number of repetitions without ever having a pattern or without ever stopping. It's an irrational number. And then the square root of 3 is close to 1.7. The square root of 4 is exactly 2. The square root of 5 is approximately 2 2/10. So square roots of numbers that are not perfect squares, like 1's a perfect square. 1 to the second power is 1. 2 to the second power gives a perfect square, 4. 3 to the second power shows a perfect square, which is 9. 4 to the second power results in a perfect square, 16. But you have all these numbers in between, 1 and 4 and 9 and 16, that are not perfect squares, numbers such as 10. So when you figure out the square root of 10, it's going to result in an irrational number. It's going to be something you can probably guess. If the square root of 9 is 3, the square root of 10 is probably, I should say approximately, with wavy lines, approximately 3.1 to the nearest 10th. It's either 3.0 something or 3.1 something. Negative square roots is a fairly easy concept to get. If you have, if you know, like for instance, what the square root of 36 is, the negative square root would be the opposite of the square root of 36. The square root of 36 was 6. And you really can read this as the opposite of the square root of 36, but it will be a negative square root because it's going to be the opposite of 6. And the root is this number right here. This is the root. So if I want to do the negative root of the square root of 49, I can calculate the square root of 49 and just put a negative sign with it. So that's how simple negative roots are. They're just the opposites of the positive root. When you want to estimate a square root, you're talking about a number that's not a perfect square, such as if you want to find the square root of 37, and you know that's close to the square root of 36, which is exactly 6. And since 37 is slightly more than 36, you would guess the square root of 37 is slightly more than 6, but it won't be much more than 6. It's probably about 6.1. And I should put the wavy lines here, means approximately equal to. If you wanted to find the square root of 30, which is a little tougher, it's not really close to the square root of 25, which is 5. And it's considerably less than the square root of 36, which is 6. But knowing that 30 is between 25 and 36 helps you know the square root of 30 must be between 5 and 6. And if you guessed approximately 5.5, I think it's really 5.47, that would be a pretty good estimate. Some calculations with square roots. If you put a square root along with some mathematical operation like the square root of 16 plus 5, this is what we're talking about when we have calculations with square roots. So you do what you can to simplify the square root. In this case, 16 is a perfect square. So this would be the same as 4 plus 5, which would be 9. If you would have something like negative 3 times the square root of 25, you would simplify the square root of 25 first, and you get negative 3 times 5, which results in 15. So heads up that this can also be written as negative 3 and then the square root of 25 like this. This also means negative 3 times the square root of 25. I'm going to show you one more and get that stuff out of the way. This is a more complicated one. The square root of 17 minus the square root of 4. In this case, we have a radical under a radical, and we have to simplify the square root of 4 first, which would be 17 minus, think about the square root of 4 being 2. And this would be the square root of 15, which is slightly less than the square root of 16, so it's to be approximately equal to the square root of 16 is 4. So this is probably about 3.9.